Okay. So hopefully this is working. I'm using Loom. Yay. Okay. Um, this video is motivated by someone on YouTube who goes by the handle of Texas Tool Crib. And he very clearly and very easy to understand explained the uh, the problem that we have with the Construction Master calculator. And that is when it does jacks, it doesn't measure them right. And that's only because there's no way to put in variables for the thickness of items. And so when they do their calculation, they have to just go with string theory. And he said that's not right, but I hate to break it to you, brother, but it is. um, anyways, I wanted to do this. He showed a really cool way, but you have to enter in a different process for each pitch change, and then irregular pitches would also be complicated. So the best way to solve this, if you're a framing professional, is either program your own calculator, which you can do with a TI or a HP, or get out a spreadsheet, numbers or Excel, and you can do that too. So I'm going to go through this real quick. This is SketchUp. I love modeling in SketchUp because it's precise, and there's some really cool plugins or extensions. Look at that. This foundation was drawn using an extension called Madik Foundations. Madik BIM. If you look up Madik or Nathaniel Wilkerson, he, I don't know how he does it, but he writes these things so that SketchUp is very much more dynamic and accurate. And it's amazing. You pick all the stuff you want. I wanted 24 by 24, number 3 rebar back and forth. I wanted 2 bars bottom, 2 bars top, and anchor bolts set every 4 feet because that's just where I live. But anyways, let's go through this and show you how animation works too, like the scenes. So from what I understand, and I'm not really a good person with layout from SketchUp, but you set up scenes like you see right here where my cursor's going. And when you're in layout, you refer to these scenes. So you would set these all up with your section views and your plan views and stuff. So what I've done is I'm going to show you from 001 to 023 how this little 24 feet deep by 36-inch wide little structure is going to go together. And it's an 8 and 12. So there's the numerical value. And the reason why I have so many decimal places is when I put it in down here, I want as many as possible to be as accurate as possible. So there you go. And it was cool because I don't think it was Texas Tool Crib, but it was, what's his name? Brian Smith, the roof slayer. I listened to him talk to Tim Euler, who's just down the road from me here, down in Port Orchard. And Ryan said, yeah, he always has a boss corner. And I'm like, man, that's exactly what we called it, a boss corner. That way all your layouts come off 2 directions off of whatever corner that is, and then you stack frame everything. So here we go. There's your sill plate, and typically it's going to have a sill seal or whatever's required in your area, whatever your inspector requires. So there's top plate and double plate. So this is your bottom plate, this is your top plate, and then there'll be another plate on top of this. We always called that the double plate. Some people call it a top plate, or the very, in framing, whatever gets the point across wins. So these studs are 104 and 5/8. So once you add a top and double plate, you get a 9 foot 1 1/8 wall. Boom. So if anybody's out there drawing a house and they just draw it to 9 feet, or they call out 9 feet, understand that using pre-cut lumber, you're going to get 9 foot 1 1/8. unless your part of the country doesn't pre-cut the same way as most everyone else. There's your joists. I'm going to just make the assumption that there's going to be some walls in here because I drew these. I think these are 2 by 10, 2 by 8. I don't remember. I could measure that really quick. Let's see. So look down in this bottom corner down here. It says 9 1/4. Wow, and it just popped up on the screen too. So yeah, these are 2 by 10, but they're overspanned. There's no way they're going to go 24 feet. But this is just for showing you how to put it together. Always follow the codes. The prescriptive code, especially in the IRC, will give you a lot of this information based off lumber species. So you've got your joists in, you got your blocking in, and your stiff back. So if you pay attention to what's coming next while you're framing, you'll snap a line down there, and you'll nail this flat board first. And these, you can pre-lay all that out so that you just kind of, you step on the board and you kind of lightly step on the loose joist, and it'll move left or right as we're oriented. And then you can shoot 2 nails down into it all the way along. So you get these all nailed together. Then you come back with your standing. This is the one that actually keeps the ceiling flat, is the standing one. And what we used to do would be a horizontal nail in the bay, in between the joists, and then an angled one down into the joist. So you'd go horizontal angle, horizontal angle, horizontal, and don't walk backwards when you do it. Do it walking forward, because you can walk backwards right off the building. You don't want to do that. Saw a guy fall down an open fireplace doing that when he was rolling black felt paper. Anyway, so the reason why these in the corner are lower is because there's going to be some hips come down. This is going to be a hip roof all the way around, 8 and 12. And that's why they're a little different. You need more space down here. So these are the layouts. And when I said stack frame, I always stack frame to where the rafters go in line with the studs. And I'm not a big fan of 2-foot on center roofs. That's truss mentality. And people are like, well, the plywood's rated for it. Yeah. Have you ever looked at a roof that's 5 years old or say, and you're in snow land? You'll see little troughs happening between the trusses or whatever rafters they used. And that's partly because everybody goes to the minimum, because most people are dollar focused. They go with the cheapest because they've been misinformed to think that all houses are equal, and they're not. So build and then own it. If you want to build what I consider baseline or cheap, I mean, if that hurts feelings. So, but build what you want to own and then own it. And if it's substandard and looks ratty down the road, that's on you. I found a couple guys, because at this point here, this is where you're going to need a couple guys. I've done this with 2 people. Like, I'd be down here with the gun, and then I would run up here, and this guy here would have this rafter on his shoulder, and then I would go down here and he would raise this one up, and I'd have them put the 2 of them together with about 1.5 inches space, just whatever, so that I could shoot. And the way to shoot these, it's all spelled out in the code book, was we would do, each joist got 2 down into the plate, and usually it was like 3, because we would go 1, 2 on the same side, a third one on the other side. Then when we get to the rafter gets 2 down into the plate, and then we did 2 face nail on this side of the rafter into the joist, and then 2 face nail from the joist back into the rafter this way. So it's like 8 nails per connection. And now this guy has 2 rafters sitting on his shoulder, and the ridge would be somewhere here on this scaffold. And then There's all kinds of ways to do this. I've had these where I could, if they're 2x6, you can nail them in and they'll kind of hold their own weight, but it's all hit or miss. And then both parties, once the bottoms are nailed on all four, both parties get up on the scaffold. You raise the ridge, and you kind of put the ridge on your shoulder and lift it up while holding these rafters and scoot it through till it's flush. And then I always shoot from the back side of the ridge into the rafter, like 1, 2, 3, 4, and then come on the other side. And so that way I'm not toenailing through the rafter into the ridge. I'm back face nailing from the opposite side of the ridge. And this is what we call the initial skeleton, because once this is all nailed off, this can just freestand. And this is helpful so that we know where everything's going to be going. And there's this weird argument. Some people, it was funny because Tim brought up, I can't remember his first name, Fusco was his last name. And he said that he argued that the end commons were different than the main commons, but that's not true. From the span, when you figure the run, which is to the face of the ridge, and then you calculate the pitch, you're going to get this common. And this common, if the roof is all the same pitch, you just take a copy of that and it comes over here in the center of that span. And those are terms like span is over everything, half span is half of the span, and run is over to the face of your ridge. All these are the same length. And so what you can do is, once you've laid out this building, you can actually measure from the layout to over layout, and you'll know exactly how long your ridge is. And that comes in handy sometimes when you're doing a more complicated roof. You can send up a ridge and maybe only make it a foot longer, just so that there's, maybe they need to nail something to it, like a floating hip or something. But anyways, this is the full skeleton, and now it won't go anywhere because it's nailed on all sides, so it'll feel pretty solid. And then this is how I would always, in the software, I can make it perfect, like it's perfectly following this rafter. But in reality, I always cut a 1/2 inch short all the way along the top edge, because the last thing you want, put something in and then you got to come back and adjust it. You should never have to do that, because that's just going backwards. Time is wrong. And it's like when you're the first guy to break out the Sawzall, you're going to get noticed. So here's all the commons filled in. And this goes really quick, especially once you get the skeleton up. 2 guys, one guy down here shooting, bang, bang, bang. The other guy up here shooting once it's flush. And a good rule is, if your ridge is about this long, come to the middle and put 2 of them in at the middle, or at least start this one at the middle before you do all the ones on the back. Because you don't want to have the weight of all these pulling on this ridge and pushing it out of whack, and then your ridge isn't straight. So you want to kind of brace it mid-span. So we're going to zoom in here. This is how this should look. I use Chief Architect a lot to do plans for permit, and in their software, this ridge ends in the middle of these 2 commons, which is part of that whole dotted line string theory layout, whatever that is. But it needs to come out here, and then that way this and this and this, they're all the same. They're all the same rafter. And that's another thing. When you build a scaffold, don't make it to where you're looking down on it, because then you got to duck under all these. You got arms, especially if you're a 6'2" framer, you probably have orangutan arms. You'll be able to reach up there. So keep that in mind. Now we added some hips. And what's cool about hips, if you use the backing bevel, which on, let me see, this is 23.09 degrees. It's really easy to do this. People go, oh, why would you waste all that extra time? Well, I'll tell you why. If you don't bevel your hips, then you have to drop your hip because you need this edge right here and this edge right here to plane across the top of these rafters. And that's not that bad. I mean, sure, yeah, you can do that. You drop the hip, whatever it is. It's like a 1/4 inch or 3/8, whatever it is. It's not very much. And then what that does down here, though, now you're changing how this sits, because if you bevel your hips, then your height above plate here is going to be the same on the hip here. But if it's not, you have to cut it different to make it plain. So if this was 4 3/8 hip or height above plate, you're going to make this like 4. And yeah, you know what? Overall everything, sure, it'll average out. You can be a little off, a little close, whatever. People like to be like that. But the more you aim for absolute true mathematical perfection, then the more this structure will true itself. And what I mean by that is if you know how to calculate all the jacks correctly, then they'll line up across from each other on a common roof. And if you trust that your numbers are correct and your jack's not quite fitting, well, then you bend the hip, or maybe the hip's got a big sag in it. You'd run a string and then brace it up vertically and then get it oriented left and right. If you follow perfection and try to get it to work and you draw everything to real world sizes, you will self-true a lot of your framing. And I've seen it. It's a beautiful thing. Things start going into place, and it's awesome, because I've had to argue with people who said, hey, I need to cut 1/2 inch off of this. And I'll be like, no, you don't. Something else has happened. It immediately tells me that there's something else wrong if you're having to cut something that was already calculated and pre-cut. So I guess I should step back and say, make sure that whoever does your foundation follows the plans, and make sure that whoever frames your walls, if that's your crew, make your wall spans exactly what the plan is. And then you could pre-cut this roof a week ahead of the project. If you know your crew can hit it, man, imagine showing up and all this stuff is cut and labeled. And since this is the only ridge out here, this would be Ridge A, and everything would just be so easy to put up. It'd be so fast. You wouldn't even have to, you could have a cut guy in a factory, and this would take him 1 day, not even, to cut all this, probably half a day, label it, put it on a truck, and then when you guys are ready for roof, there it is. And as soon as somebody complains, then I would check square, make sure the spans are correct. Don't let this thing creep, man. Be a professional. So I got distracted. Imagine that. So we got rid of the guys. So here is all the commons, the hips, the end commons, and we're about to put in jacks. And there's the jacks. And I have a calculator off to the side here. I'll show you in a minute where things get off. So on this, I think 2x8s, where I'm at 11'8" from over like an 11'8" run is where I have to put a purlin for the snow load that I have. And in some places you won't need it, but I've got this drawn where these are just floating in midair, because a purlin has to go down to a load bearing wall. You just can't lay a board across your ceiling and then brace your purlin to it. That's not made for that. Now I have done where I have the stiff back doesn't go all the way through, and wherever I needed purlins, we ran bigger joists, like make a beam out of it. But that's something that an engineer or an architect will let you know if that's copacetic. But that's how, and let me just show you how I wanted to start doing this way for a very simple reason. So I would measure down to the floor. First you hang the purlin, and the purlin has to be the same depth material as the rafters. So this is a 2x8 purlin. And you get a couple guys and you push the 1.5 inch edge up against the bottom of the rafters, and you toenail in a couple spots just to get it to stay so it won't move. And then you can eyeball down the face of this and find out where it lands on a wall, because there may be walls going front and back and stuff. You get a quick measurement, and you measure to the bottom, and whatever that is, then you also measure all the way up to the top of the rafter. And as you can see right here, I would notch out 1.5 inches by the whole length. And then when I go to put this in, I slide it over to where it's touching a rafter, and I beat the bottom nice and snug. Careful not to put a crown in this thing. And then I can shoot through the purlin, a couple nails into the back of this, and then a couple nails sideways into this rafter, and then 2 or 3 nails down into the wall. And then I come back with another 2x4 that I've notched out 1.5 inches or 2 inches or whatever, so that I can shoot into the rafter again, shoot over where I've got the purlin nailed, and then all the way down, boom, 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 into this other purlin arm, so that they're sandwiched on both sides. And this will never, in a 140-degree attic, it'll never twist or anything. It'll last. Everything's tied in nice and solid. And you just do that about every 8 feet, I think. They wanted us every 8 feet or less. So I'm sure there's a code for that. I just remember doing it like that. And up here, everybody wants to do trusses, so we haven't done purlins in a long time. And then collar ties. So collar ties, the code actually has like 1/3, 2/3 of the attic space where these are all allowed to go. Like if you had joists that were up, raised, and going from rafter to rafter, it has to be in the first third of the roof. And then in high wind zones, we also did wind ties, which are like collar ties, but they go straight across, barely underneath, like they'll touch the ridge and come across the other side. And that would be like every other rafter would get wind ties. So this is a pretty stout little building so far. And then I put the subfascia out here, playing down to the outside edge of the subfascia, and then whatever you're going to use, like we use a lot of 5/4 up here, but whatever you got in your region. So what I wanted to go back to, was it this drawing? Oh yeah, we're going to do the jacks. So there's the jacks, and then here's the dimension layer. And now that we're here, let me do this. I'm going to go, that's cool. I'm going to bring this over and go like this. Okay, so this is a spreadsheet. This is in Apple numbers, as you can see by the extension right here. But all you got to do is you need to only work in the green areas. So when you build yours, because I don't feel like just giving this away, all it would be is like giving somebody something beyond what they may be used to and get them in trouble, and then all of a sudden I'm going to hear a bunch of complaining. I'm not into that. So span was 24 feet. Ridge thickness, you need to know that. See, these are the variables that a good calculator needs to have. So when you program your own, you can program all these in. And I could show you, my HP 50G has all this. It can do all this. It's not as pretty. And this is on one sheet, so you can just print this. On the calculator, the nice thing is it prompts you. It asks you questions, and you just answer the numbers. So there's not a lot of fat fingering, accidentally hitting plus twice or something, But this, ridge thickness, wall thickness, overhang, subfascia thickness, the low pitch. So I wrote this so that it can do irregular pitches. We used to do a lot of 8 and 12, 12 and 12. This will handle whatever, 16 and 12 and 3 and 12, whatever. Hip thickness, a lot of long span hips like this are now being done by LVLs. If you don't have anything to brace under there, which that's cool. I like LVL. Rafter thickness, haven't had too many thick rafters. Rafter type, so that's a 2x8. And layouts, 16-inch on center. Old school. Okay. And then once you fill out these green things, then it calculates all the other stuff. So a 24-foot span minus 8.5 divided by 2 is 11 foot 11 and a quarter. And I used feet inch 16ths ever since when I was in Tennessee, and the truss company guys would send out trusses, and they always use this. And at first I was like, what is the deal? You know? And then I realized I had to do it here on Excel because to make it do fractions, there's a lot of weird programming you have to understand. And so that was beyond me. And I was able to make this do feet inch 16. And then I started realizing it's so easy to call out numbers. So sometimes my son helps me, and sometimes I'll say, 11 foot 11 and a quarter. So he totally gets that. Or I'll just say 11, 11, 4, and he totally gets that. And so I started converting a lot of the guys that I would run into to using feet inch 16. And the reason why I don't like just straight inches, I've worked with guys that all they want to do is inches. And they'll go, I need 167 and 3/4. And I'm like, 167. So 144 is 12 feet. So it's bigger than 12 feet. And 192 is 16. So do we have a 14? And is that even close? I don't know why people use inches. I don't know. But this tells me 11, 11, 4. So if I had to have a board that long, I need a 12-footer, and I'm only going to be cutting away like 3/4 plus whatever the overage of the board is. And that's how that works. So let's go here. I don't know what to explain. It's so simple when you do a common pitch. I don't know. So here's the rafter length. 14.4 and 3/16. I wonder if I can get that dimension. Let's try that. Dimension, D. I was having trouble dimensioning the hips for some reason. Oh, you know what? I'm not going to be able to do this because I don't have my line. Let me show you how I did this. I drew these lines. Those are the plumb cut line. But what's funny is I even got into a little bit of a argument with somebody when I said, well, there's the rafter and then there's the tail. And they were like, the rafter's just the rafter. And, technically they're right. But the way you calculate it is you calculate to over the wall and then you add your overhang. And this overhang can vary. I mean, at some point, somebody can come back and say, hey, we're changing the soffit or whatever, so we want a different overhang. So you just don't know what you might be getting. I wonder why that's hard to read. Oh, I know. I got to come over here. Let's do this. See, there's some things about SketchUp that are just sad. Okay. So it should be 14.4 and 3/16. 14.4 and 3/16. Boom. Okay, so there's that rafter. That's correct. The tail length would be along the top of the tail. That's what that is. So this whole bird's mouth thing, that's an actual code. It's called rafter notch. And let me show you. It works out kind of weird. Here it is. So in the IRC, you're only allowed to cut your bird's mouth into 1/4 of the depth of the rafter. So if it's a 2x6 and you're doing 8 and 12, then your height above plate would be 4 and 15, the next one's 6 and 9/16. So that's how I've calculated this table out. And the steeper you get, the weirder it gets, because if you did a 16 and 12, normally people are going to try to take the bottom side of the rafter into the inside of the framing, because on something like a 16 and 12, it might be a cathedral or something kind of fancy. And that's where this starts to fail. So somebody at IRC needs to really look into this and come up with a alternative. I'll see if I can find that and post. I drew a bunch of different tails according to them, and it just gets to where you're barely having any meat on the wall. See, when you go to shoot it, according to the nails you're supposed to use, you tear that up. So the main comment's correct. I was unable to dimension the hip on SketchUp, but I'm going to show you in a minute that this is how we can figure all that out, because we'll go over here and we will start with 24 feet minus 1 1/2 inch equals divide by 2 equals, so that should be our run, 11, 11, and 4, 11, 11, 4. So we're going to call that run. We're going to go 8-inch pitch. And then let's check our rafter length. That's 14.4 and 3/16. Correct. I got the rise in here somewhere. I know I do. 7/11 and a half. Yeah. 7/11 and 8 is 8/16. So let's do the hip, because so far these calculators are correct up until this point. So the hip is supposed to be 18.7 and 15/16. 18.7 and 15. Okay. I did see on this, I checked this out before I recorded this just to see if it would make sense. The hip backing angle is actually 90 degrees minus this number, and that's how you get 23.09. So all it is he's calculating from a 90-degree surface that's different than where I do it. And the 23.9 is this bell right here. And the easy way to do this is get your table saw set to 23.09. Make sure you get that 09. And then just run this through the table saw so that the blade cuts from about the middle and whatever the bevel is. And then flip it over end and run it back through so you have this diamond cut all the way along the top. And that'll just make your life easy. What else? Oh, yeah, here we go. Now we're getting into jacks. This is the part that they still can't do, because I don't blame these calculator guys. They don't know how thick the material is that I'm using. And Texas Tool Crib had a way of figuring out the difference up here. Whoops. He ran, how did he do that? He ran a line that ended up over here, and he could measure this direction, and it was like 0.46 something, if I remember correctly. But that's not really it. Let me just show you where it is. The calculator is assuming half of the ridge, and it's whatever, 3/4. Well, 3/4 horizontally is a different length than 3/4 on a 40. Let me see, 3/4 on a 45, and then it's also different 3/4 going uphill. So not only, like if you were doing half of this hip and it was 1.5 inches, yes, 3/4. But then it's longer. Whoops. I don't want to make everybody seasick. It's longer because we're on a 45. So that would be the hypotenuse of it would be 3/4. The square root of 3/4 squared plus 3/4 squared, whatever that works out to be. But then also you have to factor in the 8 and 12 angle, which is 33.69. So you would have another triangle here. And that variable can be calculated based on how thick is your hip And then that way, if you knew that and you could enter that into the calculator, you'd be all good to go. But let's look at these jacks. I'll get to a good position here where we can see these. Okay, so the longest jack should be 12, 9, and 7/16. Boom. 11, 2, and a quarter. Boom. 9, 7, and 0. Boom. 7, 11, 3/4. See how this is working? 1, 6, 14. Yeah, boom. So I've got it correct. We're going to see when I go to jacks. I want you to look at this. Where's the longest one? So the Jack Rafter 1, this calculator, and I couldn't get Construction Master. I didn't want to sign up for their extra special stuff, so it didn't work. But anyways, they have some subscription now. But anyways, 12, 8, and 15/16. That's not what it is, and that's not what it is. You know what I mean? And the only reason this becomes an issue at all, if you want to step back, is when you're a lowly little framer, you've been framing for, I don't know, a couple months, and you're putting plywood down on the roof. And as you're coming across, you're noticing that the 4-foot edge of your plywood and whatever jack you're about to land on don't line up. It's like the jacks are crooked. Because you know that 99% of the time the plywood comes from the factory square. So that's what it always used to bug me, because we would use a calculator, the Construction Master, and all of it just was not right. But the guys are like, yeah, whatever. And so if the plywood was coming off the jack, we just add a block, nail a block in there, and then just keep going. And during lunch hours, I would try to figure out the trig on this and program my calculator. And I look back on it now and I don't even know how I did it. And it's so weird. So I have faith in you young carpenters out there that if you want to be a master of your trade, dive into this stuff. Stairs and roofs and rake walls and all that kind of cool stuff that you can streamline, make them go fast. But look at this, 11, 1, 11. There is no 11, 1, 11. So that's the nice thing I like about SketchUp. It is super accurate. When I try to do this in Chief Architect, it wants to measure the center line of this, and I don't remember if it even stops at the outside wall. I think it's the whole rafter to the center. And then I'm like, what good is that going to do me? I need to be the long point. My tape hook's on the long point. So I can't use Chief, even though they have, man, it's a powerful piece of software, and they can make it look really good. They can show you a framing 3D. But even though SketchUp's a lot more work, like getting these hips to not only be the proper angle, because what I do is I'll draw a line across here, and then I'll align this to the line, and it'll protrude through all this mess. And then I got to come in with a tool called Medique Trim, another one of those by Nathaniel Wilkerson, and click on this surface and then cut off the hip so that it's perfect. So like technically I could take this, let's make a copy and go vertical. Let's go 50 feet. And then I could lay this down flat on the ground, dimension all this. Well, I already know the dimension. It's over here. Never mind. 18.7 and 15/16. And I'll link some videos that I did on a garage that was mostly valley. It was pretty cool. But SketchUp is so precise, man. The downside to SketchUp is it's slow, but once you model one thing, get rid of that. Once you model one thing, it's easy to mass produce. So yeah, looks to me like, where'd those go? There we go. Looks to me like the main commons aren't there. So that would be, look at that. So that's another thing about SketchUp I just want to talk about here. I got a few minutes. Um, Tag everything. When I say tag everything, so I made a template that has these things in it, folders, and then every kind of thing I can think of that I might be drawing, I'll apply a tag to it. And what that means is you go ahead and draw it, and then I'm going to show you like main common rafters. You highlight this, you click on this little flag, and you come over here and you click on that rafter. And now I actually have them already tagged, and I color coded them just for you so that you could see main commons and end commons are the same. Hips are red, ridge is green. I don't remember what else I did. Oh, purlins were gray. But you can turn stuff off, the visibility. So if I wanted to get rid of that, and I wanted to get rid of the skeleton and the hip and the end commons. So now I'm able to look just at the jacks. And what's nice about, so here's another thing. This happened to be 36 feet, and it worked out that it was on layout the whole way. But you're going to get a building that's an odd size, and there are people out there that they'll start on their boss corner, wherever that is. Here it is. And then as they do the rafters, everything here is breaking 16-inch, 16-inch. And then right here, they will start their jacks 16 inches past the last common rafter and recalculate all this stuff so that it's continuous, 16-inch all the way across. And the only reason they do that is to save 2 rafters. Because what I would do and what I was taught, and it makes sense to me, is wherever your last full 16-inch layout stops, and say it's only 8 inches away from this first common layout or whatever of the jacks, I'll put a rafter right at the end of that ridge where it goes. So now I'll have a close layout. And what that means is as I'm sheeting along here, at some point, I'll have to overlap that joint and probably cut a sheet just to land because it's not in layout with the 16 inches. And I think carpenters argue about everything because I've been told, oh, that's hack. I'm like, okay, sure, whatever. For production, if I can cut 4 sets of exactly the same thing, that's much better than having to fiddle-fart around with different jack lengths just so that my plywood breaks the whole way. Really? I got a track saw, dude. I can cut just as straight as a factory, so it doesn't hurt me none. But yeah, I like this because all of these on this side are the same as all of these over here, are all the same as over there, and all the same as over here. So you're really cutting 4 of each one of these with this bevel, and then 4 of each one of these with this bevel. And so you could stack them all, and just the guy's got to be smart on, there's a left and right side. As you're looking up at the hip, there's a left side and a right side. And they could sort them out. You could drive a nail through the back side and hang them all along the wall so that when they get to the point of doing jacks, all they got to do is step down, pull this up, get it snug, shoot the bottom, shoot into the hip, and then drive that nail in also. So let's just put the hips back in there. Super waheezy. Anyway, so I've taken way longer. That guy, Tool Crib, is so good at just talking and making sense. And so I get a little scattered because I just, I don't know. I love this stuff. And I'm just not that polished. But I will help you with anything I can. I just want to see the next gen just be like super badasses. You don't have to, hustling is good, but shooting nails just bang, 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 without having a conscious thought of where those nails are going and why you're doing what you're doing, that always chaps me hard. The nail gun just makes it quicker. You don't have to, it doesn't have to be like your boss saying, I better hear some nails being driven. Nah, you need a different boss. Or you should become the boss. There you go. So we're going to put the tags back over here. Build calc. What is this guy's name? Ben, I think. He's done amazing work. I mean, his calculator is like way better than Construction Master. It has a lot more features, but even he admitted that it's there's no way to program variables in here to get this right. It would take a whole different way of doing the math. And I'll tell you, my calculator, I really wanted to mark it, but I just haven't done it. It prompts you. It'll ask you, span. You type in number dash number dash number. Pitch. You type in whatever that is, 8. Maybe I'll over the shoulder video that and do another video and show you. And it's just RPN, whatever HP's RPN language is. Super simple. I'm not a programmer, but it made sense. It's sort of like if you had to write out every step in a math equation. You're doing the same thing in a calculator, and then it's asking for variables. And the reason why I really liked that was I don't always remember all the complex, like the guys that can do irregular hip jacks on a Construction Master. There's a bunch of extra keys you have to do, and I don't want to fat finger any of that. So I wrote it to where the calculator asks you, like, first you write the software and you name it. So this will be like main jacks. It'll ask you for just the variables. And once you put those in, it kicks out feet inch 16ths all the way down. And it tags it with a name so you'll know what it is, what the value is. And then let's go here. Or you can just use a spreadsheet. And yeah, this thing is worth its money. So I'll share the stair one for building stairs, because stairs are pretty simple. It's finished floor to finished floor divided by 7 5/8, and then whatever that new number is, round up the next whole number and divide back through, and that'll get you your actual rise. And yeah, another thing I don't like those 1-inch OSB treads with the rounded nosing. I just think there's too many people trying too many ways to, I don't know what their motivation is. The people that want to be praised are trying to save the planet, but in so doing, you're helping a lot of other people, big corporations, sell you some substandard stuff that, it meets code. Okay, sure. But it's a mindset. I'm a 2x12 tread guy. I like those. And trees grow back. So anyways, hey, I've got a video to show you somewhat. It shows how truss roofs, when they catch fire, how they collapse really fast. And simple 2x6 stick framed roofs, they don't even collapse. They just burn until they're carbonized. So we need to bring back the stick framed roof and the skills that it takes so that all y'all can make this being a contractor a valuable thing, because college ain't for everybody just because they put you in debt and don't teach you anything. So go be a contractor, man, but be the best and have a service heart. I'm done. It's 49 minutes, 25 seconds. And I hope you enjoyed this. It's on Loom, so maybe they'll have a SOP or something. Let's find out.